Hey, hello, and welcome to today's GFG problem of the day. Shortest path from 1 to n. Consider a directed graph whose vertices are numbered from 1 to n. There is an edge from a vertex I to vertex j if and only if either j is equal to I plus 1 or j equal to 3 into I. The task is to find the minimum number of edges in a path from vertex 1 to vertex n. So, let's see through an example. So, what it is saying that there are two conditions, right? In order to have an edge from vertex I to vertex j, right? So, for example, let's take an example n equal to 9, right? So, if we start from 1, if we start from see the vertex is numbered from 1 to n. If we start from 1, so what we can do using this j equal to 3 into I, right? We can directly jump onto 3, right? J equal to I being 1, right? 3 into 1 gives us 3, right? So 1 we can directly jump onto 3, right? Then we'll check n, right? N. So 3 into 3, again if we do 3 into 3, right? We can jump directly onto 9. So 1 to 3 to 9, right? So we are reaching in 2 steps from 1 to 9. From 1 to n we are reaching in 2 steps. Okay? So considering this formula, now we can take another example, n equal to 4, right? So if we start from 1, right? And if we take this formula again, right, we can jump onto 3 directly, right? 1 to 3, right? And then if we consider now, right, 3 into, if we again consider this one, then it will be greater than n. It will be greater than n because 3 into 3 will give us 9, right? And n equal to 4. So we can use the other formula, j equal to I plus 1, right? J equal to I plus 1, that is 3 plus 1, 4, right? So again here we are reaching in 1 and 2 step, right? 2 steps. Okay. So here, as you know that we can see we are directly given the destination n equal to 9. So how we'll have to go backwards to check, right? How many, the minimum number of steps. In order to check the minimum number of steps, we'll have to go backwards. So how we can, let's write a pseudo code, right? For example, while n, first of all, it will be n greater than 1. I'll explain this. So what we can do is we can check if n mod 3 equal to 0. If n is divisible by 3. If n is divisible by 3, then that means we can use this formula j equal to 3 into I, right? Right? We can jump onto this one, right? Using this formula. That means if n is divisible by 3, what we'll simply do, n will divide by n by 3, right? For example, if it was 139, right? 139. So n is 9 here, right? We check whether 9 is divisible by 3 or not. If it is, we'll divide. We'll go to this one right now. So n 3 divided by 9 divided by 3 will give us 3. So we are jumping here, right? If it is not divisible by 3, then we'll take our other formula, right? N minus 1, right? For example, if it was 4, n was 4, right? So it is not divisible by 3. So what we did, we jumped onto 3 by minus 1, right? And what we'll do, we'll take one count of edges, right? E equal to 0, for example. And anyways, we'll increment e here, right? We'll increment e here. So in each step, we are going to increment edge, right? Once we reach 3, right? And then we'll again check if it is divisible by 3. Yes, it is. Then we'll use this formula j into 3 into I, and we'll jump to this one, 1, right? 1, right? Once we reach 1 here, and we have reached our destination, right? So we'll simply come out and return AE. So yes, this is a solution. This was a pseudo code. Let's quickly see the code I've implemented. Same thing. If it is, we are going backwards, right? And if it is divisible by 3, then divide n by 3. Okay. And if it is not, then subtract 1 from it. and anyways increment in each step, increment number of edges, right? So this is a solution. We are returning the number of edges. So I hope please like the video and subscribe to my channel. Thank you.